Solving inequalities by multiplying or dividing. This is section 7-5. 7-4, you talked about multiplying or solving inequalities by either addition or subtraction, and you saw that that was pretty much the same as how we did equations. Multiplying and dividing is slightly more complicated. First, let me start by saying that if you multiply or divide by a positive number, it's going to be basically the same as how we did equations. However, if you multiply by a negative number, it's a little more complicated. So pay attention as we go through this lesson, and especially towards the end when we start talking about negative numbers. All right. When you multiply or divide each side of an inequality by the same positive number, the inequality remains true. That's rule number one. This is for positive numbers. Okay. When you multiply or divide each side of an inequality by the same positive number, the inequality remains true. So if I decide to multiply this inequality here by the same positive number, let's say 3, 3 times 2 is 6 is less than 6 times 3, which is 18. That inequality remains true. This property is also true for less than or equal to and greater than or equal to. All right, let's solve a couple of positive number problems. 8x is less than or equal to 40. Okay, it's a multiplication problem, so I'm going to do the opposite operation, which is division, to get my x by itself. The 8's cancel out. I have x alone. 8x is less than or equal to 40 divided by 8 is 5. I'd graph that on a number line, something like this. I put 5 in the middle. I put 6 here, and I'd put 4 here. That's probably enough numbers to tell me where I am on the number line and which way I'm headed. X is less than or equal to 5, so I circle the 5 right at the intersection. And then I look and see, notice that it is equal to, so that means that 5 is included in my solution. And then x is going to be less than 5. Is it going to be 6? No. Is it going to be 4? Yes. So it's all the numbers in this direction, less than 5 or including 5. Now let's check our answer. 8x is less than or equal to 40. Well, let's pick a number that's 5 or less. All right, let's pick 4. 8 times 4, is that less than or equal to 40? 8 times 4 is 32. That is, in fact, less than or equal to 40. So check. That one works. All right, let's solve number B, which is d over 2 is greater than 7. All right. Division problem. Therefore, I'm going to multiply. That's correct. I'm going to multiply by 2 because that's that denominator, and that would make that denominator go away. And it leaves the d all by itself. D is greater than 7 times 2. D is greater than 14. Is that true? Okay, so our solution will look something like this. Here's 14. I circle 14. I do one number on this side of 14, and I do a number on this side of 14. Now, D is greater than that. Is it going to be 13? No. Is 15 greater than 14? Yes. So my line's going to go this way. And do I leave an open circle or a closed circle? It's going to be an open circle because 14 is not part of the solution. Let's check our answer. D over 2 is greater than 7. Pick a number for me that's greater than 14. Let's try 16. Is 16 over 2 greater than 7? 16 divided by 2 is 8. Yes, 8 is greater than 7, so that answer is correct. All right, here we have a little word problem. Everybody's favorites. All right, Ling earns $8 per hour in the summer working at the zoo. Which inequality can be used to find how many hours he must work in a week to earn at least $120. Okay, so we've read it. Are we done? No, let's read it again. Always read your problems twice to get all the meaning out of them that you need to. Ling earns $8 per hour working at the zoo. Which inequality, okay, so we're going to have to find an inequality, can be used to find how many hours he must work in a week to earn at least $120. All righty. Now I have a little bit better understanding of what they're asking me, don't I? All right. We have to learn at least $120. Could it equal $120? He has to earn at least. So yes, it could equal it. Can he earn less than $120? This is what I'm not going to say that. Ignore that. Can he earn less than $120? No, he cannot earn less than $120. What he earns has to be greater than $120. And what he earns is going to be over on this side, right? Well, how do we know what he's going to earn? Well, it's going to be so many hours times $8 for each hour that we work. Do we know how many hours he's going to work? We don't. So that's our variable. That's our x. And think about it. If you worked 3 hours and you got paid $8 an hour, how much would you earn? $24. If you worked 10 hours, $80, okay? So 8 times some number is going to get you how much he earns in a week, okay? All right. Now let's solve this. It's a multiplication, so we're going to divide. Oh, excuse me. All you had to do was find the inequality. So this is the inequality. 8x is greater than or equal to 120. So there's our solution. All right, warning sign. Here we go. We're talking about what I told you to watch out for, negative numbers. All right, this is the only tricky part of inequalities. When you multiply or divide by a negative number, you have to notice that it doesn't work the same way as everything else. It's a little bit different. If I multiply negative 6 times a negative number, say negative 2, and then I multiply this side also by negative 2. Negative 2 times negative 6 is positive 12. 12 times negative 2 is negative 24. Is 12 less than negative 24? No, it is not. So what you have to do is when you multiply or divide by a negative number, you flip the sign. The sign was this way, we change it to this way. And that will make the statement true, always. Say you're going to divide by negative 5. Divide by negative 5. 10 divided by negative 5 is negative 2. 5 divided by negative 5 is negative 1. Is negative 2 greater than negative 1? No. But if I flip the sign, my statement is true. So what the rule we're going to do is learn is that when you have a negative number that you're either dividing or multiplying by, you have to flip your sign. Here's the property. This is for negative numbers. Okay, if you have a negative number, if you're going to multiply or divide, when you multiply or divide each side of an inequality by the same negative number, the inequality must be reversed for the inequality to remain true. Write it down, commit yourself to it. Okay, then we'll go on to the next slide and we'll try a couple of these in action. Here we have x over negative 3 is less than or equal to 4. All right, I have a division problem, so I'm going to do multiplication times negative 3 times negative 3. And negative 3, these two guys cancel each other out, this negative 3 and this negative 3. That leaves the x all alone, of course, is my goal. Oops. Stop right there. Actually, what I want you to do, as soon as you write times negative 3, go ahead and change your symbol. Okay, guys, bear with me a second. I'm going to erase what I just said. I made a mistake. I really don't know how to record over yet, so sometime I'll have to get with one of you technically savvy kids to show me how to do that. But for now, let me just erase and start again on this page, okay? So here are problems. X over negative 3 is less than or equal to 4. I'm going to multiply both sides by negative 3. And as soon as I see that I'm multiplying by a negative number, I'm going to flip my sign. Before I do any math, I'm going to flip that sign right away. Why? So I don't forget, okay? Negative 3 and negative 3 cancel out. I get x is greater than or equal to 4 times negative 3 or negative 12. Create my number line. Here's negative 12. What's greater than negative 12? Negative 11, right? And what's greater or less on this side? Negative 13. Okay, circle my negative 12. X is going to be greater than negative 12. So where is it going to be? It's going to be going this way towards the negative 11, because negative 11 is bigger than negative 12. And it also equals it, so I'm going to fill in my dot. And then I can check my solution. X over negative 3 is less than or equal to 4. All right. If x is what? Negative 12. If x is negative 12 over negative 3, is that less than or equal to 4? 4 is less than or equal to 4. So yes, my solution is correct. All right. I'll let you copy that down. Pause it if you want, because I'm going to erase. Oh, no, I don't need to erase. I'll just move up the page here. Okay. Negative 7x is greater than negative 56. Here's another problem for us. Okay. That's a 5. Yep. Oof. Okay. Divide by negative 7, divide by negative 7. As soon as I divide by, I'm going to take my symbol and flip it. Flip it right away. As soon as you write what you're dividing, that you're dividing by is a negative number. Those two cancel out. I get x is less than negative 56 divided by negative 7 is a positive 8. What's that look like on the number line? Here's my 8, 9, and what's less than 8? Well, 7 is less than 8. Circle at the intersection. It's everything x will be less than 8. So it's going to be everything down this way. 7, 6, 5, 4, 3, 2, 1. Let's check our work. Negative 7x is greater than negative 56. What's a number that's less than 8 that you'd like to try? Okay, let's try 7. Negative 7 times 7, is that greater than negative 56? Negative times 7 is a negative 49. Negative 49, is that greater than negative 56? Yes, it is. Negative 49 is greater than negative 56. All right, here are your practice problems. There are 9 of them. Take your time. Remember when you get to these problems that have, oops, sorry about that. Let me erase that. Remember when you get to these problems that have negative numbers, you're going to be dividing by something negative here. You're going to be multiplying by something negative here. You're going to want to, there are a bunch of them, aren't there? What are you going to want to do? You're going to want to flip the sign. Okay? Good luck with these, and we will go over these in class tomorrow. If you have any questions, please make sure you've written them in the margins on your notes so you don't forget to ask me or Miss Creighton when you have class. Good luck, guys.